like,
I think I was getting mesh and
so first you have to identify the nodes, and you have to identify something to be ground. Ground, I usually make ground at the bottom. Since we're looking for V is the difference in voltage from the bottom to the top up here. It makes sense for this to be a node, and I'll just call it V1, even though it's the same as V. And whatever voltage I get there will be V, because it's relative to ground, which is 0. And then I'll have V2 over here. And I have V3. Right here is another node. Now, relative to ground, I know that if I make ground 0, that the voltage right here is 30, because it has to be 30 volts higher on the other side of that voltage source. And with nodal analysis, we take all currents going out of the node and you add them together, and that equals 0. So in general, your equations are going to look like VA minus VB over R1 plus VA minus VC over R2 plus VA minus VB over R3 equals 0. Because these are currents. The starting voltage minus the ending voltage divided by the resistance between them.
So for V2, would it be V2 minus V1 over 6? And would I say that equal to 4.5?
That, I think that is how y'all do it. I do it a little bit different, and I'm going to stick with my way so that I don't make a mistake.
Okay.
But since I'm saying that all currents are coming out of the node, then currents coming out of the node are positive, and currents going into the node are negative. So the way I write this is V2 minus V1 over 6 plus V2 minus 0 over 1 minus 4.5 equals 0, which is exactly the same as setting it equal to 4.5, but that's how I write it. So that is my node equation for V2. So for V1, I have V1 minus V2 over 6 plus V1 minus V3 over 2 equals 0. And then for V3, I have V3 minus V1 over 2 plus V3 minus 30 over 4 plus V3 minus 0 over 12 equals 0.
Because that's a variation of the KCL.
yeah, this is taking the currents coming into and out of these nodes, and since we're
Because it's V over R, so
That's a current.
right. But in the general equation, it's equal to the total current.
Basically, what when I do KCL as KCL, I like to say it's currents out equals currents in. But what KCL really is the sum of all the currents is 0.
Yeah.
And so that's what I'm doing here, and I am saying all of my currents are coming out.
Okay.
They're all coming out,
And that's why it's equal to 0.
and that's why it equals 0.
Oh, that's. Okay.
And that's why this 4.5 had to be negative, because it's going in, but I need everything to be coming out. So I'm always starting with my node and then minus the voltage on the other side.
Okay.
Okay, so now for this first equation, if I clean it up a little bit, I get V2 minus V1 over 6 plus V2 equals 4.5. And then if I multiply this entire equation by 6, I get 6V2, oh no, that goes away, V2 minus V1 plus 6V2 equals 27, or minus V1 plus 7V2 equals 27. So that's one of my equations. This second equation, I'm going to multiply everything by 6. And that would get me V1 minus V2 plus 3V1 minus 3V3 equals 0, or 4V1 minus V2 minus 3V3 equals 0. And this last equation, first thing I'm going to do is divide all of these denominators by 2, which is the same as multiplying everything by 2, just to simplify things. So that's 1, that's 2, that's 6. And now I'll multiply the entire equation by 6, and I get 6V3 minus 6V1 plus 3V3 minus 90. No, yeah. Plus V3 equals 0. Or minus 6V1 plus 10V3 equals 90. If I divide everything by 2, minus 3V1 plus 5V3 equals 45. So now I will take I'll take my 3 equations, minus V1 plus 7V2 plus 0V3 equals 27, 4V1 minus 1V2 minus 3V3 equals 0, and minus 3V1 plus 0V2 plus 5V3 equals 45. And then it was minus 3, 0, 5, 45, 4, minus 1, minus 3, 0, minus 1, 7, 0, 27. And I get that V1 is 15, V2 is 6, and V3 is 18. So V1 is 15, V2 is 6, and V3 is 18. And what did the question ask for? It asked to find V, and V was V1. So our answer is 15 volts.
So you couldn't do this with just 2 nodes? You had to like add the extra V3 or the V1 in the middle of the circuit?
When you do nodal analysis, you are usually going to have to use all the nodes. I mean, it's generally you wouldn't have enough. If I had just done 2 nodes, I would have had 2 equations and 3 unknowns. So that's why I have to have the third node in there.
You just chose it between the 2 resistors, or it was like specifically just because there's V?
I chose that because that's what they were asking for. Yep. And that's the only reason, because if they were asking for something different, I probably would have only used 2 nodes and just treated that as an 8-volt resistor.
Oh, okay. So
But-
it wouldn't work if we simplified it in
It would, but then we'd have to unpack things after that. So we would have been able to find V2 and V3 pretty easily, but then we would have to do voltage division to find V1,
okay.
which is not that bad, but we could have done it that way.